Okay, so today we're going to talk about perpendicular bisectors. Now, if you don't know what a perpendicular means, or if you don't know what a bisector is, please go and pause this video, Google each of those terms, and then come back. I do want you to know what they mean before we start. Okay, so hopefully you're back from Googling them, and now let's talk about how we're going to create a perpendicular bisector. So the first step is you want to have a segment to bisect. So here is a segment, right? And we can actually select both of the endpoints. So select the first endpoint, then hold down the shift key, select the other endpoint, and then we have two objects selected. We can label them, so A and B. Now we would call this line segment AB. We can also find the bisector of AB just by clicking on the midpoint tool. So click on more tools, then midpoint, select line segment AB, and it'll show you the midpoint, or the center of AB is exactly there. So we can go back to the point tool, put in a point there, go to the selection tool, select that point and label it. C is the midpoint of AB. And we know a bisector is any line or line segment or ray that passes through point C. So if it goes through point C, it splits line segment AB into two equal pieces. So something like this would be a bisector because it splits AB into two equal pieces, AC and CB. And of course we can have multiple bisectors, because there's no official rule about which angle a bisector has to come from. A bisector is just any line or line segment or ray that splits a line segment into two equal pieces. So all these are bisectors. Now today we'll be discussing a special type of bisector, something called a perpendicular bisector. So let's get rid of all these bisectors that we drew. And there should be an infinite number of them, because there's an infinite number of lines that go through point C. But if you get rid of all of those, there's only one line that goes through point C at an exact 90-degree angle. And that is a perpendicular bisector. Now, you might say, Mr. Rao, well, we're done, right? We just drew a perpendicular bisector. And what I would challenge you to do is think about, is this really perpendicular? Is this really 90 degrees? Because I kind of just eyeballed it, right? What if I had been off by maybe like half a degree? What if this was actually 89.5 degrees? You can't really tell here. So what we're going to do is we're going to precisely measure. Remember, in geometry we like precision. So we're going to precisely measure 90 degrees and come up with a way to draw a line or a line segment that's exactly 90 degrees. So let's do that. The first thing we're going to do is we're going to use a compass, right? You all have compasses, and we can use a compass tool to measure out some circles that are going to be equidistant from some of these points. So to do that, first we use a segment. And this segment, I'm going to make it a little more than halfway the length of AB. So AB is this long. I'm going to use this segment to make it a little more than halfway. So a little more than AC. Now the reason for this is on Desmos we don't actually have a great compass. So we kind of have to tell Desmos we want the compass to be open to this length. And you'll see why it's going to be open to a little more than halfway pretty soon. So you can select this line segment, move it over. We're not going to really use it except to calibrate or to open up our compass tool. Now we can go to more tools, click on compass, and it'll say choose a segment that's going to act as the radius. So we're going to choose this segment because we know this segment is longer than half of the AB line segment that we wanted to look at. So once you choose a segment, you'll see this gray shadow pop up. This is what Desmos thinks a compass looks like, right? Once you start tracing around on a compass, you'll eventually end up with a circle. So if we put the hook of the compass on point A, that gray line, that gray outline, shows where the line of the compass would be drawn, right? And it'll be a circular arc all the way around point A. So we can choose the center as point A, and now it drew us a nice arc all the way around point A. Each of these points in the green arc, in the green circle, are equidistant from A. They're equally far from A, right? That's because from A to this green line, we have something called a radius. I'm sure you've heard of it before. A radius is just the length of all of the points on the outer edge of the circle to its center. Okay, now we're going to use the same radius, so a radius of this length, to create another circle, this time around B. And again, we go to the compass tool, we choose the radius, so this is going to be the radius, and we choose where to put the hook of our compass, or the center of our compass. And we're going to put it on point B. Now I like how it looks, but I really want to change the colors because I want to make sure I know which one is around A and which circle is around B. So the way we do that is we go to the selection tool, click on A, and maybe I want this to be orange, and click on the circle, and this is also orange. For B, maybe I just want B to be green. That way we know the circle around B is all the points that are equidistant from B. So now we have two circles. The orange one is equidistant from A, and the green one is equidistant from B. What we see is where these circles intersect looks like they're right perpendicular to point C. So let's actually label those points. So if we put a point up there and a point down here in the intersection of those two circles, and then we select both of those points. So I selected one, then I'm going to hold down the Shift key on my keyboard and select the other point. It'll say two objects selected, and I can label those. So points D and E intersect between the two circles. So point D is equidistant from A as it is from B. Right? If I drew a little line segment from A, that wasn't meant to happen. So if I drew a line segment from A to D, it'll be the same length as a line segment from B to D. And we can check by drawing those line segments, selecting them. So hold down Shift to select the other one, and labeling them. And you see both of those are 4.37 units long. They're equidistant. Point D is equidistant from A and B. Right? It's equally far away from A as it is from point B. Okay, let's undo some of that. And now we're back here. So when you connect point D to point E using a line segment, you've actually just created the perpendicular bisector. This segment here splits AB into two equal pieces, AC and CB, and it also does it at a 90-degree angle. So if we go to the angle tool and we measure the number of degrees between this angle, we see it's a 90-degree angle. DCB is a 90-degree angle. Of course, DCA is also going to be a 90-degree angle because it's supplementary to this 90-degree angle. So DCA is also 90 degrees. 90 plus 90 gives us 180, which we know line segment AB is 180 degrees because it's a straight angle. Okay. So that's how you construct a perpendicular bisector, a line segment that cuts AB into exactly two equal pieces, and it does so at a 90-degree angle.